Alright, the last sample problem. Calculate the enthalpy change when 25 grams of liquid water is heated. 25 grams of liquid water at 15 degrees Celsius is heated to steam at 125 degrees Celsius. Now notice all these values right here are coming from that file on D2L called physical constants. You need to download that file. So let's make a heating curve so we can keep everything straight. We're starting at 15 degrees Celsius, that's above the freezing point, so that means we're in the liquid phase. So we're going to heat the liquid water using the heat capacity of liquid water, and we're going to heat it all the way up to the boiling point. Water boils at 100, right? Then at 100, we're going to boil the water. Now during boiling, temperature stays constant. All we're doing is changing phase. And because we're boiling, we're going to use the, that should say heat of vaporization there. VAP. Using the heat of vaporization. We use the heat of fusion for melting. We use the heat of vaporization for boiling. And then once all that water is in the gas phase, we're then going to heat that gas up to 125 degrees Celsius. So we've got three calculations we're going to need to do here. So, let's heat our liquid water up to the boiling point. Q equals mc delta T. Now we're using the heat capacity of water, liquid phase, because this is liquid water, and we come up with 8.891 kilojoules. Converting everything to kilojoules is what I prefer to do. Now we're going to boil that liquid water at the boiling point. So using number of moles times heat of vaporization, so convert grams to moles, multiply by the heat of vaporization. There's my final answer. That one's already in kilojoules. And then we're going to heat that steam from 100 degrees to 125 degrees using Q equals mc delta T. And because it's steam, we're now using the heat capacity of steam. So that gives me 1.15. So when we add those three values and round to two significant figures, we get 66 kilojoules.